Hello everybody, welcome to another stream. This time about Java. Anyone hyped? So we're gonna talk about common mistakes, bugs, errors, whatever, all that kind of stuff. And how to fix those real easy. How you can fix that, how you handle that, how you work that out, you know. So we have mock-up game here, just for fun. 100% legit, random bullshit that has nothing to do with any assignments whatsoever. It's a bunch of garbage, alright? A main and a jungle, bananas, and the monkeys, vectors, lots of garbage, as you can see. And here you can see I have some things here, and if we have a mistake somewhere, so let's make a mistake somewhere, put null here, and we run that thing somewhere from main. So it's running right now. It doesn't output anything. Oh, banana started rolling. Alright, so we just implemented this null here. So let's just give it some time. And let's just make that one time. As you can see here, we'll probably find some. Yeah, banana has rolled away, and it kind of just keeps doing that. And how do you know where the problem is? Because as you can see, it just loops and loops and loops. How do you find out where the problem is? How do you know where to find the problem? Well, one of the very most important ways to debug is by placing little check marks. And as you can see, bananas rolled away. It's right over here. It's string, so it must be somewhere here that this is run infinitely many times. So as you can see, the age has to be bigger or equal to def%, which is calculated over here. And so this is ticked every 60 frames. It's doing this stuff. And so if the age is modulo check% is 0, which is over here, it will run this code. As you can see, it keeps running away, so the age is always bigger or equal to the def%. So yeah, it keeps doing that, and you can find out why, because we just changed this to null. So it's just this instead. Also, if we didn't like do this at all, we forgot it, for example, and we go to our main and we run it, and we're like, okay, that's cool, and now we don't have any output. And then you get like this null pointer exception. Why do I get a null pointer exception? So if you get a null pointer exception, don't be scared and just click on one of these. So this one, the bottom one, is the most outer layer, and it's on game.run. So somewhere in run it went wrong. Go one up. This is the stack trace base, by the way. Go one up. You can see here is jungle.tick. So it went wrong in the method jungle.tick. And as you can see, if we go inside there, jungle.tick method, we have banana.tick. And inside the banana.tick, right over here, it went wrong. So on this line, we have a null pointer exception. So this can't be null, because if this is null, then how would anything run? So jungle has to be null. And you just check, is jungle null? Like here we make jungle. We never set jungle though. So as you can see, that's how you fix that real easily. Now you already know where it is because I just deleted it, but it's easy. Alright. If we have like our own problem somewhere, let's just fix that real quick and just put that. And if we do something like this and then throw new illegal argument exception, then as you can see, if we run this, oh wait, this eat banana is never called. Jokes. In the tick here, so over there or something, and we run it, we see we get an illegal argument exception. Usually illegal argument exceptions aren't really thrown by Java, and in the assignments you used to have to throw illegal argument exceptions in some way. So it's always useful if you throw argument exceptions, or any exception, if you throw an exception, or you throw a new null pointer exception, if you can even throw those. It's always nice to parameterize them, like, hey, this is my own, something like that. And if you then play the try this thing out game, you get, hey, this is my own error, so you know it's your own error and not some random error from Java, and you're not like looking at it and be like, hey, right? So that's also one of these errors you can get. You also have errors that are like index out of bounds exceptions. So we go to jungle and we have this poor bananas, and we just make this a little bit more shitty. Just have for die 0. bananas dot size bananas. Getting bananas everywhere. And just do bananas I.tick. Dot get I.tick. And you just run it, and you get an index out of bounds exception. And index out of bounds exception, you can just click on this, and it goes to the line. And here something went wrong. The index went out of bounds, so I probably became index of 1 and size of 1. So the size is 1, the index is 1, and you know indexing starts at 0, and then 1, and then 2, etc. So the index should be 0. If it's 1, that means the size is 2, so that's too big. So something in here went wrong. And as you can see, it's just that little equal sign there, and now it works fine. So those are a lot of common errors in your code. Just redo this back to what it was. And now I'm going to talk about some catching exceptions early. If you have to throw an exception, for example, on here, and you have to throw new banana exception of some type. Execution exception. I don't know. Right? So you just throw an execution exception, for example, in your code. I don't know why you would do that. If you can even throw that thing. Just state exception, maybe. Yeah, sure. Illegal state exception. You throw that thing, so this thing throws an illegal state exception. So you just pass it on. And in jungle, this thing, why is it not working? Why you no work? It should work. Oh, you get an illegal state exception. And we got it over here, and here it is over there. And you can just say like, okay, well, let's see actually. If you look in the, it's closable. Nice. Yeah, so something with file. I need to find something with file. Maybe not scanner, but file. I don't know, something like that. We want to get a file not found exception, so something like that. And this apps scanner. Let's see if it's new scanner. Oh, this should give. Yeah, this is an unhandled exception, as you can see. So as you can see, it just throws a new file not found exception, and it's because the file input stream probably throws a file not found exception. And here you can see it throws that stuff, file not found exception, and it just gets thrown around all the time. You have file not found exception. You add that, and you can just throw it over to the next one, and you're like, hey, it's just file not found exception. All right, you just throw it over and throw it over. And you're like, hey, now it's in my main. Throws file not found exception, right? And you can't. Damn it. As you can see, you get trouble. So you'll have to try and catch it somewhere. So it's best to do that as soon as you can handle that and not wait with it until you're somewhere far, far behind. And maybe you don't want anything to happen here and you're like, right, just try and catch that stuff. And you're just like, all right, I don't care what happens, just system.exit -1. And you just handle it over here and you're done. So try to catch that stuff as soon as you can to prevent all those problems. And now we have not used imports and all those things, so just fix those with some nifty tricks. So next up is that there is one very important thing is that you have to study your syntax properly. I see a lot of people struggling because they don't know the syntax properly. That might be nice if you know that stuff. So very important to know is all this syntax. For example, if you have this.color, you know it's referencing this field and the color is just a parameter. The parameters always take precedence over fields, and so if you were to do this, color basically hides fields because it's the same name. Also little things like this, syntax with minus equals just means the same as age minus random next int, and all those kind of nifty things. And h++, which is basically just age plus 1, and all those kind of nifty tricks. And also if you put it in front of it, it means something totally different. So it's very important to just study this syntax very thoroughly, so if you see something like this, you're not thrown away into the abyss, because this just means vector3i calling the class, and since it's static, get over there, Andy. Since it's static, you can just call the class, and then .clamp, as you can see, it's also highlighted as italic, so it's a very static class. And you can just put in parameters according as here, and color.getRed, as you can see, if you hover over it, returns the red component, which is an integer. And so we just subtract 10 and put all that in, and we clamp those values. So it just does that basically. Also, if you see, I use all kinds of conventions, such as making all your public static final or private static final ints or whatever, just static finals in all caps and underscores. That's just conventions, and that makes your code more readable. Also, that you have your variables all in small caps, as you can see, or in lowercase, not small caps. Also, I suggest putting your preferences and editor syntax coloring. As you can see, it's all colorful and beautiful. That is because we have in the preferences here, in the appearance, dark mode selected, and I highly recommend it because not only is it beautiful and colorful and all that kind of stuff, it's also like bugging. Why you gotta do this? All right, so it's really easy to see what things are. So here you can see, oh, that's the methods and constructors, they're green, and blue is types, so you can easily distinguish a vector 3i. If we were to make a vector 3i equals new vector 3i, as you can see, you can immediately see this is the type and this is the variable. And if we had to do this, for example, you can immediately see not only that it's a static method and you should be accessed in a static way, you can also see you're not using a type, you're using the variable. Because here it's declared and here it's used, and so you can easily see and distinct them. While in the light team, it would be about the same color, and you can barely notice those mistakes. And with the color team, you can easily see those mistakes. Also, as I showed, if you had this, for example, you can not only see that it's yellow, but like, for example, just do something like that. Or like age, or whatever, int age equals age, plus equals age, or whatever, plus 1, something like this. You can easily see that they're the same color as this, and you know it's a parameter. And if you were to put this in front of it, you can immediately see it change color, and you know it's the same as that. So blue is fields, basically those, and those more darker purple, blue-ish things are parameters. As well as the italics here, you know it's static. If it's italic, it's static. That's nice to know. And those light green ones are basically calls to methods. And as you can see in here, in syntax coloring, enumerators have those colors and deprecated classes are that. And as you can see, you have all this coloring, auto unboxing stuff, strings, and so it's really easy to see what is what and all that kind of stuff, you know. Pretty basic stuff actually. So here, this way you can also study your syntax more easily. If you see something like this, you can see all those yellow things, they're all local variables, and those orange things are all initializers of those things. We have thread.sleep, yeah. And so it's really easy to distinct things right now, as opposed to the regular theme. Also, next, if we were to be given a problem like, let me think of a nice programming problem. Alright, so you want to know if a number is odd or even. How do you tackle such a problem? Well, you just you first off take your sketchboard or whatever, and you're like, okay, when is something odd? If x is divisible by 2, it's even, and if x is not divisible by 2, it's odd. Alright, nice, beautiful handwriting. And if you write it down, you visualize a problem, it makes it really easy to describe this. Okay, x is divisible by 2. How do you do that in Java? Right. So if we take the modulo function, for example, this looks if a variable is divisible by some number, and it just returns the remainder. So if x is 3 and we present it by 2, for example, we can remove 2 out of that and we have 1 left, and so the answer is 1. If we were to do 2% 2, then we can subtract 1, 2 out of there and we are left with 0, so the remainder is 0. Makes sense, right? And so with that knowledge, with all those little things we know, we can see, all right, to find out if something is even, then we want the modulo of x or %2 to be 0. Because in this case, if it's equal to 0, that means this is either 2 or 4 or 6 or 0 or -2, -4, and so on. So we found how to do even. So if x %2 is even or is 0, do some code, else it must be odd, right? And so you just wrote it down, and you know how to distinct those and how to solve that problem. Another problem is if you have to take a function, and that function has to take in an array of numbers, 1, 2, 3, 4, and it has to add those numbers. You can visualize that as saying, okay, yeah, I have the index of 1 or the index of 0, 1, 2, and 3, right? And you can just view an array as a list of numbers like this, and you know that, all right, we have to do add I and the next I, so we have to do the I equals, or the sum equals, this might be array R, and to R I, and we just add it. So now we add it to the sum, and we have to loop through that. So first we have 0, then we have 1, with 2, and just drawing it out helps. Also, if you have a function where you have to shuffle the inputs, so we have, maybe we have an array or even a matrix or whatever, beautiful drawing with numbers in there. You might want to just shift those columns and rows. And how do you shift those columns and rows, or how do you swap them? For example, maybe you have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. How do you solve such a problem that you have your columns over there and your rows over here? And then you can think of, all right, we first off want to scan the columns, and we have 1, 2, 3, 4 columns, and so we first read in the first row, and we get 1, 2, 3, 4 if we use a for loop for the rows, and we'll basically turn it into columns for the other one. So you can just save it somehow differently and write it like so. And you want to swap the next one, 5, 6, 7, 8, 5, 6, 7, 8, and 9, 10, 11, 12, 13, 14, 15, 16. And how might you want to implement such a thing in Java? So for example, instead of this factor 3i, we just duplicate this thing, whatever, and we just call matrix, for example. Okay, cool. And in matrix, we have public int. What does a matrix need? Let's make it a 2D matrix. I don't care enough. So yeah, this public matrix doesn't take in that. We have an array of integers, so it's an array of rows. I don't know. What does matrix need? Something like that. Alright, so something like that. And in here, you take the rows and columns. So int rows, int calls, and we just initialize the matrix with rows and calls. And we can also just make a quick print function, print matrix, and call this public put matrix and for int I. I smaller than matrix dot size or length I plus plus, and you just put that inside there. Call this k. Now you have a for loop and a for loop. And you can just access I, k, and just sys out the matrix like so. And if we are to go to our main function and not care about all that jungle stuff, and I'll teach you those little nifty tricks later. It's not really that difficult. And you just create a new matrix, alright? Public static void print matrix. No, you can't. So we just have to create a matrix. So matrix m equals new matrix, and this can be a 4x4, simple and easy. And we just call m dot print matrix. There we go. And as you can see, if we run that, we get beautiful zeros everywhere. It's just printed line by line. But we kind of don't want that. We want to print that all in one line, and we want to separate those with commas, for example. And here we just do a quick print line in between, so it looks a little bit better. As you can see, here's our beautiful matrix. It's garbage. You can also just space it like that. And yeah, as you can see here, now we have a beautiful matrix, and we printed those values, and they're all initialized to 0 because it's an int array. You don't need that shit, do we? All right. But now we want to do a public void swap calls and rows calls, for example. And we kind of want to do that kind of stuff, you know, where we iterate through all those, loop through them all. And we basically want to make a new matrix. So matrix integer array thing. M new matrix equals ints, and it has to be the same size. So matrix.length and matrix.length, or matrix 0 length, and this is really bad code, but just why do this? I'm so sick and not feeling so well, so why? Ugh, for real. And you just do name matrix. K I equals that issue. Alright, so this should work, right? And then at the end you just say matrix is a new matrix. I think that's how things work. And you just want to set those values in the matrix real quick. So if you just do m equals and then new matrix thing, something like that. Can only be used in initializers. Isn't that fun? So we'll call this array and m equals m1. Can we just do that? No, we can't, because you have to copy this over. You can't simply do this, because then you're basically overwriting it with the memory address, right? Yes, no, maybe. Well, I guess it works, but if I change m1 to be, for example, at 0, 0 to be, I don't know, like 6, 9. We print that matrix again. God dang it. As you can see, it also just changes the matrix itself, because now it has the same memory address, but for this example I don't care enough. So yeah, here we want to swap those rows, so we do m.swap rows and cols. We do that, as you can see, print an extra line in between, so they're separated. We can see those lines and cols are indeed swapped. So now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And we can see that it works, because basically the index is first I. So you can see here, we just swap the cols and rows, so it makes sense. We have the I equal 1 or 0, 1, 2, 3, and the K being 0, or let's use a different color, 0, 1, 2, 3, and basically saying using K and I instead, that first K is 0 and I is 0. So the very first value will be inserted in the first place in the resulting grid. So beautiful thing. 1. Then the second thing here is going to be I is 1, and that's 2. So we have array 1 and array 2. Yes. So K I K. The way around, please. I'm so rusty. This is array 0. This is array 2. I'm so good at this. I swear, I'm master at this. So I is 1. We take this value from array 0 and we put it into K0. So K0. What am I doing? Like, what am I doing? I'm so terrible at explaining today. Like, what am I doing? No, wrong. I 0 0, K is 0 1. There you go. So this determines the columns basically. This returns the rows, if that makes any sense. Like, I think this explanation is going to be horrible, but stick with me. So first K is 0 0. So as you know, K and I. And just make a visualization for yourself. Like, I'm making a visualization for myself. You probably don't understand anything, but it just helps to understand how things work. And just take the next K, and I just take well, you take K as the column, so 2, but here you take it as the row, and so you take it as the row, so it goes from there to over there. It just puts 2. Go to the next one, you put 3, and it goes over there. The next one's 4, and you put it over there. The next one is 5. And instead of going to the rows, we swap to the columns. And so this one goes over here, etc. And just making a beautiful, a little beautiful thing for yourself. It may help, but this was a terrible explanation. Sorry. Anyway, it also helps to organize your code. Like, I can write something like public static void column, and yeah, so new or integer is something like this. Alright, cool. And maybe it's nice to put like a thing over here and say appri plus equals 3. And alright, we want to do system.out not print line appri, and it's horrible. Like, what does this thing do? It's like horrible. CTRL+SHIFT+F, boom, cleans your stuff. CTRL+SHIFT+F, one of the most important little shortcuts in history of life and everything. Alright, so remember that CTRL+SHIFT+F is going to be useful as heck. So let me just create a new file. Boom. CTRL+SHIFT+F is formatting code. CTRL+SHIFT+O is organizing imports. So if we have to use scanner here, new scanner, as you can see, what I did is, instead of going over here and importing it, if you have another one like file f equals new file, you have those unimported things. If you hit CTRL+SHIFT+O, boom, it just adds that. so you don't have to write that yourself or do other things. And those kind of things you can just find online, and it's useful to have those kinds of shortcuts on hand. F11 is for debugging, so you can just easily just hit F11 and debug your code, and we'll run it in debug mode, and I'll head over to that soon. So actually, let me edit this thing. Something like that, I don't know. Alright, so next is CTRL+F11 is just simply running it instead of debugging it. As you can see, this is debugging that's running. So if we had something matrix, and we can just run it with CTRL+F11. As you can see, it just does this basically the same thing. Ctrl+D is very useful if you have a line extra somewhere. For example, I have it Sys.out here and maybe another one. How do I? Yeah, I have like a bunch of those, like so. And I want to delete them. I can just do Ctrl+D and deletes all those lines. And if you mistakenly deleted some extra lines, you can use Ctrl+Z, of course. You can copy a line downwards by using Ctrl+Alt and down arrow, so you can just create a lot of those. You can just, for example, do this. I don't care enough. And you just do that. That's pretty useful. Also, you can use Alt, so you can just move one line down, or you can select multiple lines and just move them all down at the same time. So you can select more, like less, just, you know, just play with your code like so, and just move them around. You just format that stuff and just break everything. But that's all nifty editing tips and tricks. If you want to look at the documentation of something, you can just hit Control and click on them, and you can look at the documentation of system within the Java editor. You can just see like, oh, properties, yeah, that stuff. As you can see, you can just hover over methods and see the documentation there, or just over here for system, or you can just open them up like where they're implemented and you just go there. Alright, commenting out code is also very useful, like as I shown here. I might not want all the matrix stuff, so I can comment that out and comment that out, or comment that in basically, by hitting Control and slash. So you can just easily switch code on and off. It's also very useful. Ctrl+Shift+J is also useful if you just want to generate Java documentation, if that works somehow. I don't know. Somewhere in here. It don't work. Somebody lie. Why you lying? Why you have to lie? Maybe you have to something like this. No, it don't work. Whatever. I don't care enough. Scrap that. It doesn't work. Alright, code formatter, as I showed you, and code highlighting are very important to help you reading your own code. Also, in Alt-Shift-J, yeah, there you go. So you can just hit Alt-Shift-J for things and just generate the the basis documentation, and you'll usually have to edit those. It's nifty. So just go here and just boom. You can just say add some monkey. And you can also just write get and then a variable name. As you can see, you can just click on that and generate the getter real quickly. You can also just do that the same for setters. For Boolean types, Boolean banana no equals true. I don't know. You can just use is b, and that's the getter for is banana, and this would be the setter. And so you can easily create getters and setters that way by just using code templates, as well as writing sysout. You can just write syso, and first template here, you can see what it will be replaced with. You click that and it will replace that with the correct code. If you hit Control Space, you can see all the templates over here. You can just do an array add, and you have the array type and a new array type. So maybe more ints and ints, and it does all that stuff. It's an array copy and whatever. And so you can just use code templates like that. I love to use the for one. Easily generates the code for you, so you don't have to type it out yourself. So you can just write for, boom, and you're done. Easy. Yeah. And if you go here, you can also just go to source, and you have all kinds of other things you've seen probably by now. And one is useful is to generate constructed user fields. And you can see it just generates that thing, and you can usually just delete the super above there, and it just initializes this bananas with whatever you support it with. And so that's nifty. We can just generate that. It saves a lot of time. Also, if you have a name here that is like, I don't know, you have a very shitty name over here for one of your variables, just stand on the field, hit Alt-Shift-R, and you can rename the thing with bananas, and it will find every instance of that variable name and rename it. So you don't have to go through your own code and be like, oh, I don't like this, I want to call this banana list, and you have to change it over here and over here, and it's just a ton of work. So you can just refactor it by just standing on there, hitting refactor, rename, or just Alt-Shift-R, as you can see, and we'll just rename that to, or you know, something. And you can just do that to every single one of them, which is pretty nifty. Also, if you have like errors like this, you're like, hey, I have an error. Usually syntax errors are easy to fix. You just read it and you're like, all right, I'll token this token over there, expected after this token, we expected this thing, and it's like a lot of weird things. You're like, oh yeah, this just has to be like that, you know? And sometimes those mistakes are more difficult to fix. Like, for example, if we do this for, and let's just generate a for loop real quick, like so, and we have like a new array here, int array equals int array 3, and we just want to initialize every value of there, and just say int I equals 1, or just put I. You're like, hey, it doesn't work. Cannot be resolved variable, create a local variable I. You know, well, I guess. Why does it not work? Why does it not work? You're looking at your code for ages and you're like, this should just work. And you're looking at those things and there's like syntax error, insert dot class to complete expression, and you get all kinds of bunch of errors. And if you get a ton of errors for something as simple as that, you can usually just hit CTRL+SHIFT+F and format your code. So let's just comment this out real quick and just format our code, and we see this weird semicolon because it was over here and we accidentally wrote that. If we format the code, it will immediately find that for us. That's nifty. Just remove it and uncomment this. Yeah, and that might also be a very nice thing to do. But now at least it will work and it doesn't give any errors. And such a semicolon means actually this over here will be the statement for the for loop, and this is just an empty scope. I mean, you can just do like array equals 0, null, I don't know, something. So yeah, if you have a semicolon over here between your for loop and whatever you do, you might not notice that, but the formatter might come in handy for that. So you can see that prematurely. Yeah, what else? All right, so for example, we have this, right? Array I equals 0, and we just want to print the array. So print sysout print line array, and let's actually do this in main. Let's comment that stuff out as well. Fair enough. Bit of a section here, and let's run it. And we get that, and we're like, huh? Why? And you're like, why doesn't it print the array? And so you don't have any errors or anything. This is the horrible bug. It's like, how do you fix that? Luckily, we know that we're printing an array, and if you try to print an array, if you print anything, basically, all right, so let's just change this to an integer array, I guess. Oh, like integer. So it just turns beautiful pink because it's unboxing stuff. We can see integer, all right? Go to the toString, CTRL+F, toString. All right, it does all kinds of weird stuff. But let's go to the integer array, or I believe the toString object. All right, here. Basically, those primitive types, they use the toString method when you try printing them. And as you can see, it prints getClass.getName, so it gets the name of the class. As you can see, getClass basically just gets the class name. Somehow it's native, so it's some wonky stuff in the background. Let's go back to our toString. There you go. And you can also read the documentation and see toString method for class returns a string consisting of the name of the class with the object instance at the @sign and in the unsigned hexadecimal representation of the hash code of the object. In other words, this method returns a string equivalent of that stuff. And so that is why if we print our array, it will print all that garbage. So first it will print the class name and apparently some garbage here, and then the hexadecimal representation. That's why it doesn't print our array as we wanted. So you'll have to print every single integer on its own. So you'll also have to do that in a for loop. So you can just do for loop over there and just move it in there with Alt. And you can just print every number. And then we see, hey, it's 0, 0, 0. It's all 0. Why is it all 0? And it's all zeros, and we're like, why is that 0? And we'll have to look somewhere into our integer, and we see that we have a 0 over here because we just use our system printout line to find out that the array length or the array contains all zeros. For example, if we use it somewhere, they're all full of zeros. So we might want to have I over here instead, and it's 0, 1, 2, and just a simple print line or little print function can help a lot to find bugs. For example, if we go in banana and we have to alright, so -1 or something, I don't know. Hopefully this gives an error somewhere if we put the game back on. And as you can see, we get a legal argument parameter, a legal argument exception. And color parameter outside the expected range, red. What does that mean? You go here and you can easily see, alright, so it's wrong over here, and it should read the error messages. You can see an argument is illegal, so one of those arguments has to be bad. It doesn't expect that. And as you can read this, it says color parameter outside of range, red. So it must be something with the red. The color int r is going to be for red. So this one we just initialize it over here. It's wrong. Why would it be wrong? And you know that a color has to be between 0 and 255. In this example, you can easily see that that this is -1. But for example, we just had a variable like int min equals 1, and we are to use min over here. We can just oh no, wait, never mind. We can just see what the value is of new r by using sysout new r. And so we will get printed the number, and you can see, oh, it just decreases, and 5, and then -1. Hey, that's not supposed to happen. You know that the error must be somewhere over here. Usually it's you don't put it over here, and it's way more complex, but just putting a simple print line with a variable you suspect to be wrong can help a lot. And you can find error and spot it and change it. And you can also, like, for example, if you have like 7, for example, here, you run that, as you can see, it gives different outputs. Oh, don't clear the output log then. As you can see, we might expect this to be different, and you can just see what the actual value is by doing that. Another way to do that is by putting a breakpoint over here, alright, and just going into debug mode. So F11, and it just does that. And if you go to the debug mode, here you can switch the view from Java to debug to Java to debug. In debug, we have a variables thing. I just reworked it somewhere. There has to be a variables tab, and you can see this age, color, run. You can see all the variables, and you can see color or jungle, whatever, and you can see all the values within there. Pretty nifty. And you can just look at the color, jungle, whatever, random, seed, whatever. Alright, so the vector 3i. We have a vector 3i somewhere. I created a vector 3i there. Huh. You can just change variables here, I think. Can we not? You can just change the value to like 5325 and just live edit the code over here. And we can also just, or the memory, we can also just live edit the memory. Let's say like vector 3i dot x sysout and put that over there. And also nifty trick is Shift plus Control. You can just select full words instead of full letters with just Shift, so you can just more quickly select things. You can just live edit the code. You just save it over here, and the pointer will jump back up to the beginning of the method. And if we step through this, right? Just what? Oh, I stepped out. I stepped into. All right, so we come in age, we come in that stuff. Cool, whatever. All right, B tick. Oh, the age percent is not. Huh. Oh, we have to run it till the next time it comes here, and we have our factor 3i, and we want to just live edit this value to 323. And if we now look at our print, it will now print it out because we as you can see over here, it printed 323 because we live edit the memory. And it will print that new memory. And if we don't edit this time, we can see it is 0 because we didn't edit the factor 3i, which was 0. And so we can also just change this to -1, for example. And by changing that to -1, you can see if we run it again to the next time it hits the breakpoint, it prints -1. As you can see, you can just live edit the code. You also can just do like you are, and we want to make this a string, so we just put it over there and red. So we save it again, we run till next time it hits there, step through it a little bit to here, and then next time it prints 0 and red, which is 215, as you can see here. You can also just change this to like 3523. That will probably give an error. If we run it again, yep. As you can see, in the debug, it will say that it's now in color, right? So now let's step out, and you can see it gives an error because we changed our memory to something it did not expect. You get an error. So yeah, that's how you can use the debugger for changing variables in your stuff, like in your code. Let's debug again. Let's stop at the breakpoint. You can also see the breakpoints. You can turn them on and off over here. It's pretty nifty. So yeah, live editing code, live editing memory. It's pretty nifty. You can just delete this. Yeah. All right, this is now deleted, and now we just, yeah, it's done. It's gone. All right, let's just go in here and just delete the vector. Does it terminate the program though? I don't want that. Why not just delete one? No, it just terminates. That's unfortunate. Yeah. That's unfortunate. We can't delete that stuff. We can only change the values. You probably can. You probably can't delete anything without it terminating. Which makes sense though. So yeah, that's what you're limited to. You can just edit them freely. You can even make the code not work by your editing, but That's okay. And you can also just edit those memory addresses. So we can just do new vector 3i, and we can just select 5, 7, 9, or 8, and hit OK. And as you can see, it just puts all the perfect values in there. So you can just change the value to x equals 5, maybe. Oh, x cannot be resolved to a variable. New vec I, and you can just construct it with 0, 0, 0. And it will also just set all that perfectly fine. So that's pretty nifty about the thing. Let me fix this. Like, it's annoying me. It's annoying me to the point that I have to change this. It's absolutely annoying. Absolutely annoying. Where can I change this? Come on. This is really frustrating me right now. There we finally go. I hate everything about Twitch Mobile. I hate it. It's garbage. I changed the title 2 times in Twitch Mobile and it didn't change it. Sucks. Anyway, System.out println is gonna be your hero, and this debugger is absolutely amazing. You can just change the code and yeah, it's awesome. And you can just terminate your program over here, the output. So yeah, I think I have kind of explained the debugger quite nicely, probably, I think, maybe. Is there any questions about the debugger? Anything you want to know? Anything in particular, like about Eclipse you want to know, or if there exists such a feature or whatever? Like, actually, a quick little question round. Or maybe for people who already know quite a bit about Eclipse, if you have any suggestions to what I should still explain, drop those suggestions now. I will explain how big it is in another video, but that is beyond our scope for today. We're only talking about bananas and monkeys and about what monkeys do with those bananas. Anyway, project importing. If we have a project, let's go to some nice place and you go to your folders or your projects, and I'm just going to duplicate my tutorial folder and call it tutorial_2nd. Alright, so I just went to my file explorer and I duplicated and called tutorial2nd. You can see that as importing a project. You can just call this project tutorial_2nd. And as you can see, the wizard will automatically configure the JRE and project layout based on the existing source. And that's how you import a project. And this is nice if you have some source code from online and you want to see how it works, and just import it like that. And as you can see, it's basically the same as what we had over there. You can delete the project and delete the whole thing, and it's gone. You can also just close project real quick by doing that. And by doing that, nobody can see the code. You can't see the problems in that code. And if you open that, those problems return. Secondly, library importing. If we want to write a test, for example, for this, and we call a new class, and we call this any test. And in any test, we have an add test, and we call this public test. I don't know, public void test, and it does something. You can see this is going to be resolved to a type, and you can just add unit to the library to build path, and it will add it, and then it just works. Let's say you want to configure other things in the build path. You can just go over here in the Java build path thing, and under source and under order export, whatever, there's also libraries, and you can see JUnit has been added as a library. You can add more libraries, so maybe you want to use maybe you want to use Maven manage dependencies for some odd reason. Like maybe you want to just add that, for example. You can just do that over here. Jerry system library, why not just add it? It's already added, but I don't care enough. You can just yeah, just add libraries like that. You can just remove them by selecting them and removing them. You can also just add external jars, so you can just find some jars from online and just add them to your project, and all that kind of beautiful stuff. My test, what does test have? I wanted to make some, yeah, cool. So here is JUnit has already added. Auto completion is also very useful. As I showed you, auto completion is a hero by control space, and you have all the things in here. And here's all the test asserts that there exist, and you can see a ton of them. Assert that, assume, no exception, fail, and all that kind of stuff. So just using control space, you can see everything you can use. You can use the equals function with null, and done. Totally useless, but it's totally possible. And what else? Annotations, also very useful if we have, for example, int Andy, and we have like a warning like this. We might want to suppress the warning, so you can just use unused, and you put that annotation above, and it will suppress the warning, so you don't see that warning in your plugging thing. So here we have one item. This delta is never used, but we kind of don't want to use it yet. Maybe we want to implement that later. So for now, we just want to suppress that warning, and it just empties the problem log. And we have an error. We just want to go over there and just be like, let's annotate that with suppress warnings. No, you can't, because this isn't not an error. This I mean, it's not a warning. This is an error, so you'll have to fix it. You can't annotate that. Do you have something like int I equals 0 and oops, la di da, and maybe J K L M U V W X Y and Z. I perfectly calculated that amount, And you can just suppress the warning for that and suppress the warning for that. But there's an easier way, and just put it above the entire thing, and all those warnings will be suppressed of that type. You can also just have a different warning, for example, x equals x. So it's a dumb thing to do, but it has no effect, and it will give a warning in your thing. And you can also just put all over there, and then all the warnings are suppressed. I would not recommend this myself, but if you're really desperate and you just want to narrow down your problems and you have tons of problems in here, you can just suppress the warning temporarily, but I suggest fixing that later on and just delete all that stuff. The formatter is also nifty because here in your preferences, general, editors, Java, I don't know where it is, formatter. Formatter, where are you? Formatter, come on. Alright, Java formatter. You can here edit the preferences for the formatter, and if you're like very nippy about this, you can just do that, for example, or preserve white space. You can just have different indentation. Maybe you want less indentation, like 2 or 1. Maybe you want bigger indentation size, like that. Or maybe you're a spaces only person and you just want to do something like that. Basically just switch it to tabs only or spaces only. And statements within switch body, maybe you want to tab them out like that, or maybe you don't want to have statements within box B, or break statements, maybe you want them on the same line. Maybe you have like some weird things, maybe like that for some reason. Ugh. Or braces, you want them on the same line or next line. So you can just set that all over here and just hit OK when you're done, and it will change the formatter. So next time you press CTRL+SHIFT+F, it might, for example, add more tabs over here. This will all look different to your stuff, and it's just formatted differently. Also, if you have a piece of code, like say like this, and you want to write this out like so, and just have it all neatly organized. So you see your matrix like so. Just want to format this custom format. So you want to customly format this like so, and maybe you're even pickier about it. You want this all on one line, like so, and like so. And this is neatly formatted to you, so you can read it really nicely. If you then hit CTRL+SHIFT+F, you're working with someone else, and hit CTRL+SHIFT+F, and just destroys your beautiful layout. You can just put a comment here with add formatter off, and you can enable it after that with formatter on. And now if you format that stuff, if you do it correctly, I think it's like so. Yeah, right. So now, for example, we have this and that, and this is not nicely formatted. And over here, we might have some badly formatted stuff. If we hit CTRL+SHIFT+F, it will fix those. But for here, the formatter will be off for a second. So you can neatly organize all your data structures like in 1, in 2, and those will just remain intact like so. And if you format this really ugly like so, this will never get formatted, no matter how much how many times I use F. Alright, so that's pretty nice. You just remove those, and as you can see, if we format now, it boom, it just destroys it. So yeah, that's how you turn the formatter on and off, and how you work with that formatter. Also, a lot of people ask a lot of questions really quickly, and they don't take the time to fix their problems on their own and think about them on their own. And I really suggest visualization and experimenting. If you're not sure what numbers to put in here, you can just experiment and be like, right, so a bunch of garbage over here. Maybe we don't want this to be like so, and so we just I actually like this format, so let's just do this. Maybe one change this value to like 0 and this one to 53, and we run it again, stop it real quick, and maybe this is what we want, and you can just experiment a little bit until you get the result expect. Also, if you're not sure if you should for example here call it with jungle.addMonkey or the regular one, you can just experiment a little bit and see if it works like that. If you can just use quick fixes, and you're like, okay, make that static. I do not recommend making everything static. If you have this error, cannot make a static reference to non-static method addMonkey, do not click change addMonkey to static. It will be a daisy chain of statics. You'll have to change everything to static, and eventually you'll hit something like this and you can't staticify your stuff anymore, and you're screwed. So you'll have to try and use an instance. Jungle is an instance. Jungle is an instance, and it's not static. That way you'll fix your problems. So experimenting is very important. Also, just being like, right, sysout delta, just remove that. As you can see, it also puts a green line under here, and see it says infos. At least one of the problems in category unused is not analyzed due to a compiler option being ignored. Yeah, so very descriptive, and you can just remove that, for example, and see if your code still works. And beautiful, it now prints the delta in between every time. That's pretty nice. You just can experiment a little bit until your code works just perfectly fine the way you want it to work. And I'm just messing this code up more and more. How do you write proper tests? If we have a beautiful method, where is our matrix? Let's use vector 3i. I want to write a test for vector 3i. Let's just duplicate this thing. Vector test. Let's just call it vector test. We'll edit this, and we'll call this test, for example, clamp. So in, we can just have multiple tests, and we'll want to see if the clamp function works. So we have clamp in, clamp out, and clamp on, for example. I don't know, very descriptive names. For example, you always want to test your methods that can return something or whatever, and not the methods that, for example, like here, print things. Like those methods you can usually ignore when you want to test them, because usually you can just call the method and see if it prints the correct output, and you don't have to write a test for it. For swap rows and columns, you probably want to write a test as well, but we'll just do it over clamp. And so we'll just call clamp. So vector clamp, and we have variable 5, maybe 0 and 10, and it's perfectly within. So we now can assert true, assert equals. Can assert true that this is a variable var int var equals that, and we expect this to be 5 because it's clamped between 0 and 10. 5 is perfectly within that, and you can just do that. Clamp out, we want it to be outside the range, so 15, it should be 10 because it's clamped to 10. All right, so that's the max value. So if it's above 10, it will default back to 10. And we want to do clamp on. So if this is 0, we want it to stay 0 no matter what, and not do weird and funky stuff. And you want to test for those edge cases, basically. Is it 0 or 10 or negative? You want to just take a very big subset of edge cases and weird things that can happen if you have a method that returns an object. Let's see, we have something cool. Does anything return an object? Let's have this just return an object of integer return new matrix. Let's just add that to there. Swap rows calls. We can just have a beautiful test over here and call this you can just write let's see, what can we do? We're a jungle. All right, there you go. Some garbage people. Just get the fuck out of my chat. Get burned, motherfuckers. Right, so, yeah, that's what you get for being just assholes. Let's get back to the real shit. All right, so we have this test over here, and we have swap rows and columns. Is that we want to test swap rows, calls, test. We just basically want to test if those get swapped properly. And yeah, I can make you mod. I can totally mod you. I hope that works. Do that work? I don't even know. I don't even know if that work. Do that work? Do that not work? You can always try. Do that work? Do that not work? Yeah, it should work, right? Try chat. Nah, you're not mod yet. Select mod. You're already a moderator. Which is why you know show up as moderator. Anyway, I don't care enough. So yeah, let's get back into this stuff and not get distracted. So yeah, we assert this to be true, and we can just swap rows and columns test. So we have to make a new matrix 4 by 3 by 3, make it easy. So matrix m equals new matrix. And we want to do m dot swap rows and columns, and we want to make it easy on ourselves, and just do m dot the moderator here is my student TA, so he gets moderator status because yeah, he's illegal, but that's okay. I will not care about that for now. Yeah, so m dot matrix, you can just set the first value to be 1, or like this, and then you just have matrix. Just want to check if the matrix at 1, 0 in this case is equal to 1. That's what we expect at least, and we want this to be true. Dot matrix. And let's just run some unit tests. Run as unit tests, and boom, everything is green. Look, oh my god, green bar. And he taught me this means good. If there is an error, however, in your test, for example, we check if variable equals 1. We can see our tests are bad. I get an assertion error. And if you actually put, you can see add fraud vector test clamp on, right? Clamp on in our vector test class. We expected 1, so you can just look at this. You can just check at the value over here, and you see it's a variable equals 1. And you try to think about this, and you want to know why it's not working, and you're like, my clamp function might not be working correctly. Usually though, if you have errors in your tests, that's really annoying to fix. So that's why before you write tests, you always want to write down the expected results and code it and program it properly so your tests are proper and actually correct. And tests have to be really simple and easy to understand so you can prevent making errors like these. And these are very easy examples. You can just write, all right, so kind of just we expect that 0 is within the sub in the set 0 to 10, so we expect 0 to remain 0. So you can just have a little comment and you write it out, and you know it has to be 0. It's a really simple, easy test. Right over here, it's a little bit more difficult, and you can just write this over here as, so suppose we have a matrix with, and then you can just build your matrix over here with 0, 0, 0, 1, 0, 0. So, something like that. And we want to swap rows and columns. We should get, and then you can see 0, 0, 0, 1, 0, 0, 0, 0, 0. This is what we expect, and by doing an easy test like this, you can see, all right, this is rows. So this would be the rows over here, this would be columns. So it's in the second column. So 0, 1 is the second column, there is a 1. And when we swap it, we want it to be 0, and you can also just have a second test, so, and also the original place has to be 0. So we check this is 0, and we want to check this one became 1, so that can be done by going to the second column, or the second row in this case, on the first column, and check if that's 1. So then it should correctly work, and by having a little visualization for yourself, you can easily write those properly. So matrix is 3 by 3, as you can see in the beginning. The first, or this, yeah, the second column is 1 over there, and you swap it, and then we get that. And then our test is correct, and our function is correct. Say we did something wrong, and we did something like that. Then our test should go wrong. And we know swap rows and columns test went wrong. But because this is a super easy test, and we know the test is right, we know for a fact that there's an error in here. And as you can see, it doesn't give any output over here. But if you do assert equals, however, you can just generate a matrix over here and say if the m is equal to n, and you have a matrix n equals a new matrix, also 3 by 3, and n dot matrix 0 or 1 0 equal 1. And so after swapping rows and columns, it should be in there, and these two matrices should be the same. However, this will not simply work like that. Even though you think you did it right, you can see it's comparing memory addresses because it's doing that kind of weird stuff. And that's why you want to override your toString over here, and instead of super toString, you want to return a string. So string s equals nothing, and you can just do 4, and you just override it like so. You can just use a 4, and you have to do 2 for loops, and you want to do matrix 0 0 as we have it over here. This is my print line, except we don't want to print it out, we just want to append it to our stuff. So we can just use the toString method, and instead of doing this whole print thing, you can just use the toString method and just print the toString. So you can just delete that for now, and do s plus equals new line, like so, and then we return s. And now if we in main, instead of printing matrix, we now do m, or like print sysout print m, and we do that over here as well. And we run this. Okay, all that garbage. Let's just put a breakpoint over there because I don't care enough. Just debug it, and as you can see, the console, it prints just fine. It adds an extra new line, but that's fine. As you can see, our toString works, except our swap rows and columns does not work, as we just explained, because our test failed. Over here you can see your test, it fails, and as you can see now the toString function is overridden, we can see what it expects and what it was. So we expect this to be that, but it was that. Okay, so I think you have to do it like so. Yeah. So we expect, of course, that after the swap it's over there. So this is what it has to be tested with, and the second argument is what is to be tested, right? And so now you know the output and see what is expected and what the actual output is. You can see easily what went wrong. You can see, hey, it's different. But even if they're equal, even if the swap rows and columns just works fine, where is it? There it is. Even if this works just fine, it seems like it should work. 0, 0, 0, 1, 0, 0, 0, 0, 0, 1. It seems the same. But that's because we didn't have our equals method in matrix overridden, so we want to override that equals method. And instead of doing address comparing, we want to compare every value within that matrix. So let's just compare that. And instead of doing all that garbage like so, the best way to do it is to just do source, generate hash code and equals, and boom. You can just have the hash code over here. It's nice. You can always use that. It's always nice to override this stuff. So this equals function here just sees if it's the exact same object, it will return true. If the object is null, it will return false. If the class and the object's class are different, it will return false. So if they are not different, then we can safely cast it. If we didn't do this check and it's a different class, it will just die over here, as Andy told us. It will just give us a runtime exception. And if the arrays, and we have a deep equals matrix auto.matrix, if it doesn't, then we return false, and if it does, we return true. And so this is very just like beautiful and stuff. But maybe you just want to write your own for loop over here, and you can just do like not that. Write for, and another for over here, and you can do your garbage over here and just use the for loop instead. So yeah, you probably all did that kind of stuff for pretty easy stuff by now, hopefully. For the exams, they're going to be way more difficult. And as you can see now, hey, it works because the equals function is being used over here. So yeah, that's how you make your tests work properly, and that's how you debug them. That's by just writing them correct in the first place. You know what values to consider. Testing is basically you want to try correct values, you want to try things that should throw errors, maybe this rows and columns swap should check if the integer array or like matrix dot length not equals 0. You can just do if length is not 0, or if the length is 0, or to be even more precise, is smaller than 1, so it's smaller than 1, we want to throw the illegal argument exception. Illegal argument exception. And in here you can say, for example, the length was smaller than 1. and a lot of exclamation marks, so you know that the error is going from yourself, because a real good programmer would never write that. Cough, cough. Yeah, no. For obvious reasons. And also you want to check if the matrix length of the thing why you not work. Because I'm really smart. And you also want to check the length of the second array within there. And if these are not correct, it will throw an error. And so if we here make a new matrix of 0, 0, we actually, oh wait, we want to have an attest illegal size. We have a size test here, public void illegal size. We make a new matrix, matrix P equals new matrix 0, 0. Cool. And if the matrix is 0, 0, we also want to just do m.swap or p.swap rows and columns, and this should throw a thing, an error. So we can have a rule, and then we have expected exception equals some stuff, and I quickly have to figure out how that stuff works again, because I kind of forgot. 1 second. All right, so yeah, I know again, this is the correct thing. And if you paste something, usually the imports are already added immediately. And so you do public expected exception, and what is the variable name. The expected exception is none in this case to start with. And over here we expect something, so we can just do expected exception equals then expected exception dot expect or I'm so like dead today. 1 second again. Not showing code by accident, that would be terrible. Yeah, I'm so brain dead today. Sorry for the terrible explanation. But yeah, this is what you do. You just have a legal argument exception of class is expected, because here we throw that. And now run this. Where you have to test has errors. Why does it have errors? You have to import that. And now you should be able to run that. Illegal size. You got purged, bruh. Alright. Illegal argument exception dot class. Yeah, don't insult mods. Yeah, questions are in 4 minutes, so. So yeah, we expect the exception, but we see that we get in Java lang array index out of bound exception. So this is what we expect, but we get an error. that we didn't expect. And it might be because of this part over here. And we cannot check that if that's 0, so maybe it's better to do an OR if over here. And voila, we fixed our code. We fixed our code on string. That's pretty nice. I mean, there you go. We expect this specific exception. You have to take it as specific as you can. You can also just use exceptional class. I mean, it works perfectly fine. But if we were to go over here and we were to change this back to end, it will just work fine. Except our code doesn't work fine because we expect only an illegal argument exception. And if we were to specify the illegal argument exception as broad as we can, lol, everybody gets purged in chat, just gets destroyed. Oh, why you have to do that? That's why you don't have to illegal decknash. But wait. Hunter didn't do anything wrong, did he? Yeah. Well, anyway. So yeah, this is how you write tests in very basic stuff. This is not fraud because this is shitty as basic Java, which can be broadly yeah, toolbox. How do you? I got ended right now. I got ended. I don't know the English word. Okay, then that moment when your high school teacher apps you on Facebook and asks you to do something. That's strange. Anyway, whatever. That's random. All right, so yeah, I hope you kind of learned anything. I have to apologize. I'm like so dead today. Like I helped a billion people today, and I am one big brain fart. So let's just wrap it up here, I guess, and just have a quick overview of what you should think about and everything that's very important to remember. So yeah, first off, let me just get my notes. It's just, where are you? New. And so it's a lot of experimentation with your Java, and just a lot of experimentation, a lot of testing, and writing your own code does really help with writing code. I'm so good at life and everything. All right, so things to remember are that the common mistakes, bugs, and errors that you make can be easily fixed by reading the error messages properly and clicking through the. So let's actually just remove this illegal argument exception test, and since it's testable, just make a failed trace, and you can just click on the failed trace, or if it's in there, you can just click on it and see where the error is located, and that makes life a million times easier. Catching exceptions early is basically just that you don't throw it over to the next one you just don't care about, just throw it and throw it and throw it. If you can handle it as soon as you can. Hidden tests in web lab theories, that's why you have to write proper tests and have every single case that there is. And that brings me to a point, and that is coverage. You can run your factor test as coverage, and it will mark your code in a certain color. If it's green, it means the code has at least ran once. If it's yellow, it has only done one of two branches, and so usually that's on assert true. It should always be yellow because it should always return only true. So that's fine. And red means the code has not run or an error has occurred on that line. As here, it's expected, so that's all fine. And the coverage on vector test is therefore very high. If you then go to matrix test, that's the class to be tested. You can see that 56.6% is covered, and this toString function is not tested, and so therefore is red. The hash code is not tested, and therefore is red. The equals method is tested, except it only checks this. Okay, it's not the same object, so as you can see, that does a lot of problems. And so if we are to write some more tests over here, and we just did like a test matrix A was a matrix of 1 by 1, which is a terrible matrix, and matrix B, and you want to do assert equals. The expected is obviously that they are, so we expect that it's true, right? A equals B, or A dot equals B, and make some beautiful auto unboxing stuff. So equals same values, and you have one for same values, for example. You have one for equals same addresses, and here, for example, you do A dot equals A. And if you now run your coverage as follows, you go to matrix, you can see this turned green. It used to be yellow, but now the object is the exact same address, so that will return that. We now go to here and say matrix A and matrix B. We say new matrix. Instead of that, we just put in null. We're comparing a matrix against null, and equals not, doesn't equal, it's just null because we are null boys. So yeah, you get that, and if you now run it with coverage on, it should be false. Sorry, we want to kind of like run the entire thing, so we can just run as JUnit test coverage as actually, and now that is all ran, and now you can see also the second case is done. And if an if statement has one of two branches missed, that means it's either went inside the if statement or it skipped the if statement. And so you kind of want to test every single branch. So now we want to change, say like, okay, it's not null, but it might be a different type. So it's like a string, e equals nana. So these are not equal. Equals not, because we have a beautiful string and d. I mean, we have a string. Unlikely argument. You can see it's already complaining in here. Suppress that. All right, so now we run the factory test again. And we look in here, and as you see, this is also turned green. And so we only have one more, and that is if the thing is actually a matrix, except it's not the same matrix. So matrix string A and B. This is a new matrix, cool. But it might be a different matrix with 3 by 2. And we have beautiful string because we have a beautiful not same matrix. And don't call your tests like this. This is a bad example. And there you fix really easily bugs. Now you run it, and let's just put it over here. Coverage as unit test, and now that runs. And as you can see, the entire equals function is green. That means we have we went in this if statement, and we somewhere we returned true, and somewhere else we just skipped over. Somewhere we add this false, and sometimes we just skipped over it. So now every single branch is done. So yeah, and that you can do for hash code as well, and for toString as well, and for this if statement, for example, there's 4 branches because either this can be true and this false, or this can be false and that true. And there's just multiple ways that this can be tested, so you have to think about that when writing tests. That's how you can use coverage as. Is there any questions? So yeah, now's the questions time. If there's any questions, anything you want to know, anything in particular, please ask me because I won't have more time after this. I'll also get in the WhatsApp group as well if people want to ask questions. My PP is very big. I don't want to talk about it because then it would be very long. Okay, let's see if the WhatsApp group has any questions. Any questions? Ask them now. So many people asking questions in private chats. Thank you very much. Much appreciated. Mr. Black and White, we have some volunteers who want to be destroyed. So have fun with that. Meanwhile, I'm just gonna look at some other comments. Thank you. Thank you very much. Destroyed. Huh. It's a cookie of your own dough. Like, I'm not your brother, man, if you're even a man. You're just spamming chat with bullshit and crap and not like really adding to this Twitch stream, you know. So here we have a bad example of someone doing something dumb. Let's just show that off. There is another one, pink dude. Throw him out. Plus, I don't love your bands. They're getting old. Stale. Stale memes. Old. Bad. Die. Thank you. Destroyed. Alright. yeah, it's okay. They're quote unquote friends. I don't know. Lately they're just being annoying. I hope they won't be more annoying. So to you, stop calling me on Steam, please. Like, it's annoying. Like ANNOYING, annoying, right? Anyway, so there's here a beautiful thing someone sent. And that's this toString, which I just explained, that you have to override the toString if you are working with your own objects. So otherwise, it's going to print the memory address, as we have seen before. So if we take this override and we just comment that out for now, oops, and we print that thing, whoops, we have so many debug stuff. We can see it prints the class name and the hexadecimal thing, and that's why you want to override that, so you get proper stuff written. All right, let's see if there's more problems. Any more problems? All right, this is a very, very, very important thing. Like, if you don't know this, you're probably missing out on a lot of stuff. And it is regarding the study and some things, and how to properly prepare for exams and stuff. And this is some information that I can only give to you, because there has never been a better advice as the following, and that is, there we go. If you go to this link, you'll get free gift codes for Steam, and be quick, because they will be handed out over the next 20 people that follow this link and fill in the form. So if you want free money, free Steam gift cards, go over here. It's even okay. I'm sorry. I'm I can't. I just no. Yeah. This was. Did you just notice this? Like even the simplest tasks, I can't even. I can't even do the simplest tasks. It's horrible. I give up. I give up life. I just give up life. It's done. Easy. Bye. I'm done.